So let's go over characteristics of different types of bonds. That's the ionic bonds and the covalent bonds. Now the first thing to remember is that ionic bonds happen between a metal and a non-metal. So they react between something that is negative and something that is positive. Remember, when you're talking about metals, they are going to lose electrons. That's why they become positively charged. Non-metals gain electrons, they become negatively charged. Covalent bonds only happen between non-metals. Okay, only between non-metals. Those are covalent bonds. So let's start. What are the characteristics of ionic bonds? Now you need to also know that ionic bonds are also called electrovalent. Okay, electrovalent bonds. So ionic compounds are also called electrovalent compounds. Electro meaning electricity. So because there is an attraction between something negative and something positive, that's where the electro is coming from. So one thing, when you're talking about uh, cover electrovalent compounds or ionic compounds, an example, I'm going to put an example here, which is sodium chloride, where I've got the sodium that is positive and then the chlorine that is negative. This is one example. So the characteristics: one, they are made up of positively charged and negatively charged ions. Okay, so they are made up of ions, positive and negatively charged ions. And then again, the other thing, one characteristic is that in aqua solution and in molten state, they conduct electricity. Okay, they conduct electricity, that is in the aqueous state or molten state. Now, what do we mean when we are saying aqueous and molten? So when we are saying something that is aqueous is something that is dissolved in water. So when you get to dissolve these in water, they are going to conduct electricity. For example, you get sodium chloride. Sodium chloride is simply table salt, the salt that we use. So when you dissolve sodium chloride in water, like the salt in water, electricity is able to pass through. Now in molten state, molten means more dissolving something by heating it. For example, the way candle is, when you get to put candle on fire, is going to what? Is going to melt. So in that state, when it more looks like a liquid solid like that, that is what we call the molten state. So in that state, ionic substances or ionic compounds are able to conduct electricity. So apart from this, the other characteristic is that they are soluble in water. Okay, they are soluble in water but insoluble in organic solvents. So they dissolve in water but they cannot dissolve in organic solvents. Insoluble in organic solvents. Now what do you mean by solvent? A solvent is simply a fluid or a liquid where something is able to dissolve. That's a solvent. Okay, now so we are saying this cannot dissolve in organic solvents. Organic compounds, these are compounds which contain more a carbon and a hydrogen. For example, alcohol. All right, that is an example of an organic solvent. So meaning that sodium chloride cannot dissolve in ethanol or methanol, that is alcohol. Another characteristic of this is that they are non-volatile. So what does it mean to be non-volatile? So something that is volatile is something that can evaporate. So ionic compounds, they are not able to evaporate like that just by themselves. They are non-volatile. And they are mostly solids. Okay, their solids at room temperature and pressure. So when they are just alone without disturbing them, like just at the temperature of the room, they are going to be solids. Apart from this, they've got a high melting and boiling point. The reason for this is when you are forming ionic bonds, you are going to have a lot of positive and negative charges attracting each other. So you are going to see that the positive charges, these charges are arranged themselves in this manner. So because like there are a lot of them, positive and negative, it is very difficult for you to be able to separate these charges away from each other. Remember, just when you get a magnet, the bigger a magnet, the more difficult it is going to be to separate it from the other one it has attracted. That is why if you talk of very big magnets, they can be able to attract more when you're talking about garbage collection, maybe cars or metals that have been destroyed are going to use big magnets. That's why they get to attract very heavy things. That is because the attraction is such high. So because the attraction is such high, for you to be able to separate these is going to be very difficult. That's why they've got a very high melting point and boiling point. So for you to melt something or to boil something, you have to separate these attractions which are between them. That is why it is very high. Alright. And then the other thing is that the high melting and boiling points are due to the strong electrostatic forces which I've shown there of attraction between the ions. Breaking such strong bonds require greater energy because of these high boiling and melting points. Okay. Some of these compounds are used in the industry like in the furnace, for example, calcium oxide, which has got a melting point of about 2614 degrees Celsius. So see, it's very big, like for you to be able to melt these compounds. So these are some of the characteristics of ionic bonding. Now, I mean ionic compounds. When you talk of covalent compounds, an example of a covalent compound that you can give is water and carbon dioxide. So they are made up of molecules. Well, when you're talking about a molecule is a compound that is formed from nine metals. So, covalent compounds are made up or they are made from molecules and then they have got a low melting and boiling point. Melting and boiling points. And the reason for that is that the attractions in them are not that strong as compared to ionic bonds. That is why the melting and the boiling point is a bit low. So they are usually insoluble in water. They don't dissolve in water mostly. Now, because they are insoluble in water, meaning they are going to be soluble in organic compounds. Okay. Alright, apart from that, now the reason as to why they even get to be soluble in organic compounds is that their bonds, the bonds in covalent compounds are able to interact with the bonds in organic compounds. They can't interact with the bonds uh, in in water. So that is why you are going to get to understand this more, in that when you're talking about things which are charged, they attract other things which are charged. Things which are not charged, they also attract other things which are not charged. Water is a charged molecule even if it is a covalent bond. That is why ionic compounds can dissolve in water, because they're also charged. But most of the covalent compounds are not charged and water is charged, so they are not able to dissolve like that. So apart from this, covalent compounds are also volatile, meaning they're able to dissolve. I mean, they're able to evaporate just by themselves like that. They can convert from liquid to gaseous state. Again, they do not conduct electricity in solid or molten state. It's just more like the direct opposite of what we've looked at on the ionic bonds. Alright, so these are some of the characteristics of these types of bonds, and we really need to understand this because that is why some compounds behave the way they do. So if we say we talk of this compound, we give its characteristics, we should be able to determine whether it's what, whether it's ionic, it has got ionic bonds or it has got covalent bonds, just by looking at the characteristics.